In this podcast, we're going to talk about scientific models, and we're going to delve into Dalton's atomic theory. Um, Atoms are very, very small, as we've already seen, and therefore they're very difficult to study. So, throughout the years, scientists have developed atomic models, and they use these to try to explain the experimental data that we've collected on atoms. So an atomic model is not a exact description of an atom, but rather it's our way of depicting what we've learned from the experimental data. All right, Dalton's atomic theory. So we did a computer lab on Dalton's atomic theory, and we saw that Dalton developed his theory from the experiments of other scientists. So he took what other scientists had done and the results they had gotten from experiments, and he was able to use that and kind of put it all together to come up with the atomic theory of atoms. All right, so there's several constructs to his atomic theory. First is all matter is composed of extremely small particles called atoms. This is not the first time that somebody's had this idea. The Greeks actually had this idea, but it is included in his atomic theory. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. So basically, he says there's all these little things called atoms, and there's a bunch of different ones, and they're a little bit different. So each of the different ones has slightly different sizes, slightly different masses, and slightly different properties. And this is, a really revolutionary idea for this time. He also went on to state that atoms cannot be subdivided, created, or destroyed. So he said, this is the smallest it gets. And then he says atoms of different elements combine in simple whole number ratios to form chemical compounds. So this goes back to the law of definite proportions, which you've already learned about. So basically, water is always going to have two hydrogens and one oxygen. And then he said that in chemical reactions, atoms are combined, separated, or rearranged. This is the basis for the law of conservation of mass. So these are all really revolutionary ideas for this time. However, we learned later on that Dalton's wasn't exactly correct on a couple points. So there have been several changes made to his theory. The first one involved his statement that atoms of a given element are identical in size, mass, and other properties. And then if you have a different element, it's going to differ with size, the mass, and the properties. So we know now that elements have isotopes. So you may have carbon with 7 neutrons, and you may have carbon with 6 neutrons. So carbon 12 and carbon 13. So we know that they're not all exactly identical in mass specifically. All right, the next thing that we have modified from Dalton's atomic theory is the statement that atoms cannot be subdivided, created, or destroyed. Well, we've now discovered that these things can happen. They can happen in nuclear reactions. So we've modified his idea, made it a little more specific. So we say in ordinary chemical reactions, these things don't happen, but they can happen in nuclear reactions. So we can cause these things to happen, when we're talking about atomic warfare, nuclear bombs, nuclear energy, things like that. So we can cause these things to happen in those type of reactions. All right, so we see that Dalton's ideas were very revolutionary for his time, and they were the basis upon which all other models of the atom were built after him. So they're very important to the world of chemistry.